Hi, power of ensemble learning with Python. In this section, we'll talk about the random forest for classification. We'll use the gradient boosting and bias optimization. We'll use a cat boost to handle a categorical data. And in the end, we'll implement blending and we'll implement stacking. Random forest for classification. In this video, we will test the classic ensemble method, the random forest. We'll tune the model. We'll compare the basic random forest with logistic regression and tuned random forest. The dataset is the same from the archive as a wine quality. Let's go to the code. Well, let's start from importing the libraries. As you can see, it's almost the same as in the previous video. The only thing I added is a random forest classifier. Okay, import this and import the data and split the data to the train and test. Fill an A. And let's build a baseline with a logistic regression. Okay, the baseline is here. And now we can write a fit predict function. It has the if scalar variable, so we will use a random forest with scalar and without. And we have set up the number of estimators, which is a number of trees. Maximum features, it's auto, and mean sample split is 2. It's a default. And as you can see, it's pretty close to the decision tree. Now, actually, the random forest is a forest of trees. So the main idea is you're building a tree, then another tree, then another tree, and you build the tree not on the whole dataset, but the fraction of dataset. And in the end, you'll receive a different trees with a different prediction, but then you will average them. You'll receive a much better result than from the previous one. Well, it's covered in theory, but we won't go that deep. We'll just tune the random forest and use it. So let's apply the function. Okay, now we can apply the basic function with scalar and without. And as you can see, the results are much better than baseline, but I think that we can tune it. Let's try to tune with the number of estimators, which is the number of trees to build and to use in blending. Okay, let's go through 20 to 200s and we see the results here. Yeah, and it looks like the best one is 160. It's clearly the best one. Okay, let's use it. And now we can try to find the best maximum depth. We will search between 1 and 20. And the number of estimate is 160. Let's go. 1, 2, and 3 is not enough. It's clearly okay. It's going better and better. And okay, it's even better, much better. Oh, great. So, what will be the final one? Well, it looks like the best one is in 18. The quality is 0.702. Okay, and now we can try to find out the best maximum feature splitting. Go on. And it looks like that 0.2 is the best, but let's wait. Yep, it looks like that 0.2 is the best one. Okay, I think that we will stick to the 0.2, it's clearly the best score. And now we can proceed further to the mean sample split. And we will search between 2 and 10. And we already have our number of estimators, 160. Max features is 0.2. And max depth is 18. So let's search for it. It's better. Wow, it's worth. Looks like 3 is the best one. Yep, 3 is the best one. Okay, let's use it. So it's 160, max feature is 0.2, mean sample split is 3, max depth is 18. And now we can try this both scalar and with no scalar. Let's try it. Well, it looks like there is almost no difference between random forest with scalar and random forest without one. And that's the case. The random forest doesn't need any kind of scalar. Well, you can see that there is some droppage in the quality, but actually it just could be noise. But anyway, remember, you don't need to scale the data for the random forest. And now we can calculate the quality, the gain. So the gain in comparison with the baseline is 39%, almost 40%, it's a huge one. And the gain in comparison with the non-tuned random forest is almost 12%. That's a huge. Okay, we learned that even the basic random forest is a powerful model, but tuning process is quite close to the decision tree and will end up in a much better model. And we don't need to scale the data, and that's great. So if you just forgotten to scale the data, don't worry, it's okay.